Hi everyone, I'm Julia and I'm here with the communications team talking about the LunaSat Power and Data Model, the LPDM. In this module, the LunaSat Power and Data Model, the LPDM, is a collaborative effort from our software and communication subteams. This is designed for you and your team to put all of your hard work into action through the LPDM. We will go over how to use the program that runs the LPDM and walk through the first section. By the end, your team will understand the limitations of working with a set power and data limit. If you run into issues along the way, reference this slide deck and the accompanying question and answer document. Our progress so far. The lunar surface is a harsh environment with variability in temperature, radiation exposure, and much more. Our lunar version LunaSats are actively being designed and tested for this rigorous habitat. Beyond the LunaSat, we are building industry relationships and securing funding for our mission to the moon. The LunaSat Power and Data Model. So why is this important? Our team has curated a system, the LPDM as mentioned, that allows for the LunaSat component configurations to be modified within reason. The LPDM helps mitigate any issues that may occur during our lunar mission, including compatibility risk, power limitations, and mission constraints. The purpose of this is to understand how to work the configuration settings while keeping in mind the limited power and data usage for the LunaSats. The LPDM is an important part of what will make GLEE's mission successful and give you access to the data received from the lunar surface. So a little bit of the introduction into the LPDM. Together we will traverse this PowerPoint and the accompanying Jupiter Light program. Our module is hosted on a GitHub Pages website running Jupiter Light for ease of access and storage purposes. It's recommended that teams use only one device when accessing the Jupiter Light due to the bandwidth of the GitHub pages and the multitude of teams and individuals that we have. Teams should consider the configurations together. Keep in mind that if the notebook does not launch for you, you may need to use a different browser, Safari, Chrome, Firefox, or Microsoft Edge, for example. Throughout the LPDM, we will learn to use a new coding language called Python and go over the basics of how to run notebook cells, rerun cells to save any changes, nested forms, and other specifics. Together, we will go through one sensor as an example and discover the parameters that we can modify during our lunar mission. When accessing Jupiter Light, we will open it up. We will open specifically the model folder. You and your team will discover the module 0.0, the introduction, to get accustomed, and then we will continue on from there. We will open up module 1.0, and you're welcome to follow along.
Hello everyone, my name is Bento Salazar and I am on the communications team here at GLEE, and I am going to walk you through our temperature sensor, Notebook 1.0. And so before we begin, here are some important notes to consider. You must save progress of any edits to the Jupiter Light. You can do this by either hitting the save button or by running the cell. And remember, editing the cell does not show you the results of what you edited. You must rerun the cell to see any new or changed outputs. Be sure to only edit the needed variables. The variables needing change will have none written in the cell blocks, and that none will be written in green text. Cells that do not require edits will say so with green text above the cell block. The first section of Notebook 1.0 temperature sensor contains the overview, which you can see here. This section will give a brief introduction to the sensor itself. The second section of the notebook contains the configuration section. This section will dive into the different primary configurable modes that you and your team can interact with in the next section, creating configurations. And so within the configurations mode, this section will go into detail about the 4 primary configurable modes for the temperature sensor. These are continuous conversion mode, shutdown mode, one-shot mode, and therm and alert mode. As such, we will not go into detail about them here. This section both here and in future notebooks, may contain information about the limitations of different inputs that pertain to the cells you can edit. So be sure to read them very carefully. Now for the next section, creating configurations. This section allows us to create our configurations for our data and power usage. As such, this section will have in-depth details about the particular numbers we can input for our cells. It is important to pay attention to limitations to particular modes and the numbers we can change for each setting of that particular mode. For example, if we choose the shutdown configuration, this mode is limited in the options we can input for both the conversion cycle time and the number of average conversions. These inputs must be 0. However, we must still give the modes a duration and a sampling rate number. Otherwise, it will not have time to conduct a single temperature conversion. And here is where on that notebook it says that shutdown mode is limited in the numbers we can input. And now for the next section. Before the next section, actually, is when we can actually put in our configurations. So I myself have already filled out configuration 1, 2, and 3. You can input any of the numbers and configurations you so choose to. Just note the limitations of each one. So if I want to run this cell, after I have inputted everything, I'll hit this little play button to run the cell. And so now, that data is stored in the notebook. Now for the next section, configurations for a lunar mission. During our time on the lunar surface, it's important that we choose a proper mode to optimize our data collection and power usage. For this section, we should only consider using the one-shot mode or the shutdown mode. Revisit the configurations you set in the previous cell with these limitations in mind and make any changes needed. And now for both calculating power usage and calculating data usage. We can calculate the power and data usage for any configuration to get an idea of how it's affected by the various settings. Run the cells to see the graphical outputs of your configurations. This is important for teams to keep in mind when reassessing their science case missions that they may wish to pursue. So, notice how this says, do not modify the following code, simply run the cell to see the output. So, all that means is hit that little play button and it will run that cell. And so here's the graphical output of my very random configurations that I made prior to this video. And then we do the same thing for the data usage. So we run the cell and here's that again. And now for putting it all together. We wrap up this LPDM section by looking at the power and data usage of all of our configurations together. The three graphs that will appear during this section are the active times, power consumption, and data consumption graphs in their respective units along the y-axis, and in seconds along the x-axis. This information will be revisited later after all other modules have been independently completed by teams in the combined power and data model. As such, be sure to run the final cell to store the data. So, if we were to run the cell, you will get a graphical output that looks like this. And so, again, there is the active times, the power usage, and the data usage. As for that final cell, this is what will actually store it for us to pull it up in the combined power and data model in that notebook. So be sure to run it.
Moving forward in the LPDM. Now that you have finished your first notebook, follow these additional steps before each notebook. These steps should be completed when notebooks 1.1 to 2.0 are first opened. Go to the toolbar at the top of the screen, click Kernel, then click Change Kernel. Under Use Kernel from Preferred Session, select 1.0 temperature sensor.ipynb, assuming that Module 1.0 has already been opened and run. Finally, modify and run the appropriate cells. If you complete these steps after running the notebook, rerun all the cells. This process ensures that the stored data in one notebook can be retrieved in another. Teams will not be able to run Notebook 2.0 at all if these steps are not followed. Final steps. To verify this is completed, look at the numbers on the left side of each cell once they have finished executing. This number in the brackets on the left-hand side of the image corresponds to the order in which the cells were run. If the kernel was selected correctly, these numbers won't reset with each notebook and will continue incrementing. So if the last notebook ended on 5, then the next notebook will begin on 6. If these steps have been followed and an error is still being displayed, students should revisit each notebook and follow the above steps again. If cells seem not to be executing at all, they should consider either shutting down the kernels by clicking the symbol underneath the folder icon on the left side and clicking Shut Down All or refreshing the page.
And now for the next steps. After you have gone through all of the previous slides, you have now created a dataset that can be used to configure the LunaSats. As we update this version of the LPDM, expect to re-explore notebooks 2.0 and 2.1 as we expect changes to occur. When the LunaSats and their flight code has been finalized, your team will be asked to again complete the LPDM if there are major changes. You will then send us your finalized dataset as a text format that we will then put into our code. While we are still looking for our ride to the moon, we hope that this project has been valuable to you and your team, just as it has been valuable to us here at Glee. Continue to look for updates on our mission via our Instagram and our monthly newsletters. Thank you.